continuing my effort to get rid of all the giant networking devices that I've built up and haven't gotten around to shooting videos for, so I can throw them away, or at least resell them if possible. This is the McAfee IntruShield 2700. This, I believe, takes the record for the most expensive piece of networking hardware I've ever bought on eBay. The original price from 2006 is $34,995 US. Which, yeah, I can see why. I mean, inside it, as we'll see, there's lots of custom stuff in it. But, man, that's just crazy. Anyway, what this does is it's a intrusion prevention system, so it's monitoring traffic and making sure everything's safe on your network. We've got a console port, an auxiliary port. I guess this may be for linking two of them together or something. It's another serial port. Management port, which is 10 base T, I believe. We've got a flash socket, and mine didn't come with anything in it. There is an internal one that's populated though. Two GBIC ports, which are similar to these more modern SFF adapter things. These things take an internal copper connection and turn it into either gigabit copper, gigabit Ethernet, whatever you need. And there's 6 100 base T ports and 3 more 100 base T ports. Those are supposedly for response. I'm not sure what that's supposed to be. I don't know. It must be some software configuration. Supposedly everything can be rearranged as needed. And I'm just going to flip this giant thing around and we'll see what's going on around back. One thing is also there's little cutouts at the very bottom for LEDs. I think they're actually surface mount LEDs on the actual main board. Got this giant thing flipped around. As we can see, there are 2 trays here, and at first I thought these were for hard drives, but they're actually blower style fans that easily swap in and out. They're filthy, by the way. You know, so you can do it while the system's running. You can just pop it out, swap it, back in. There's a redundant power supply setup, although obviously there's only one installed. This has a little locking bracket on it. Just take this off. And inside, one power supply and one dummy card. Yay. I've never actually seen a redundant power supply system with a dummy card in it, although I do understand the need for it to communicate that there's no power supply in it as opposed to a broken or dead power supply. With the cover off, we can begin to see why this thing costs so much money. I mean, I don't know if it's worth $35,000, but there's certainly a lot of expensive stuff in here. We've got tons of FPGAs, specialty controllers. I think this has a PowerPC chip on it. There's RDRAM, there's SDRAM, there's bought-in switch mode power supplies. It's crazy. This thing must have cost a fortune to make, but you know, $35,000, I don't know. So over here we've got the cage for the power supplies. There's an SD card down, or sorry, CF card down here, and one giant custom motherboard, which I'm going to get out, and it will probably take a lot of screws. So I've taken most of the stuff out of it. You can see that the fan carriers have this plastic connector. This is what plugged into the fan, the 3-pin connector. And you can see how this is movable. And the reason for that is that it allows it to get a solid connection. If there's any warping or anything, it won't snap it. One has some give so it can line up. And you can see that it's filthy. Inside, hooked up to the cage for the redundant power supplies, is this AVC fan. This is an 80mm 12 volt. It is loud and it is dirty. I have actually powered this thing up. I didn't do it on film because, one, I want to open up the power supply, so I don't want to deal with capacitors being charged, and two, it doesn't do anything. It just makes a lot of noise, and I'm sure it's showing something on the command line. I just, I have no interest in fiddling around with the command line on this thing. So, yeah, it's not too interesting powered up. There's no video connector or anything like that. And, yeah, the two blower fans are giant Sonon type ones, and they're just loud and dirty. So I'm going to wash my hands and continue filming. I've got the little PCB from the dummy power supply. All it has is a Renesas M51957A, which is a small IC used for resetting CPUs. Presumably they use this to send a signal to the microcontroller handling the alarms and whatnot. It's got a cap to set the timing and whatnot, and a couple resistors. Not much else on it. Okay, I think I got enough screws out of this thing. This is the Emax power supply, 350 watt. This system I only think pulls about 100 watts or so while it's running. It was fairly loud when it was assembled. Those fans are quite noisy, but let's see if we can get this off. Okay, looks like one of their pretty standard power supplies. Very high density due to the small form factor. Thermal grease on everything. Very nicely constructed, considering the size. Obviously, in a power supply, you don't want stuff too close together, but when you're limited by size, what can you do? So it's got the single 40mm fan, and yeah, seems well built. They're Nippon Chemicon KY series for the most part. All looking like they're in good shape. This is the backplane board. You can see the huge jumper links between the primary and the backup power supply. Fan connectors and huge solder holes here for the connections for the 5-volt rails and whatnot. There's a little daughter board here with a chip that is in a socket but has been glued down, so it just popped out of the socket. That's kind of funny. I didn't actually I thought this was soldered in. I didn't really look at it. So we've just got a little board here. This is probably just a simple microcontroller. You can tell because it's got a little resonator there. So it's most likely just a little microcontroller handling all the power supply functions like the alarms and whatnot. And I'll try and pull that chip off in a second. And there's another thing here. Oh, this one's in a socket too. It's also glued. It's just some passives. And this is running off to the board. So I think what this is this is the power on circuit. I think this is telling the board to start up. Yeah, there's a simple chip here that's probably like an op amp or something. And there's some, I think these are polyfuses. Kind of a boring board. Let's see if we can get this chip off. Where's my specialized chip removing tool? It's most likely a microcontroller. It's got a sticker on it. Oh, it's an Atmel. Hang on. As expected, this is actually a microcontroller. It's an Atmel AT89C2051, which is hard to focus on. It's an 8-bit microcontroller, nothing too fancy. It's got 128 bits of internal RAM, and yeah, not much. It's just a very, very low power 2K of flash microcontroller. This is the coupler for the front Ethernet connection. The internal wire is actually a shielded twisted pair, which are fairly uncommon, at least in homes. And we've got one connection on this side and an upside down connection on this side, which is a little odd, but yeah, this should be somewhat useful. Alright, now we're going to go over the motherboard. I'm going to bring it in close for each chip because there's a lot of stuff on this board. This thing's loaded with power supplies, it's loaded with network processing engines, memory. There are Xilinx chips everywhere on it. It's just absolutely packed with stuff. And this is probably a 10 or 12 layer board, just judging by the edges. I'm not sure. There's no like little clear section to tell you what layer you're on. So I have seen boards that are like 27 layer. Some Cisco boards were just insane. I mean, the costs involved in just making the board are astronomical at that point. But yeah, I'm gonna go into this and figure out what's on it. I trimmed off this pin header, which I think is the JTAG programmer for this Xilinx chip right here. Okay, so let's power it up. Goes through a pattern at first and just blinks on a couple of them. And then after a moment, it starts doing a Larson scanner, like a Cylon. And after a little while, it seems to just repeat it. Also on the board are LEDs for all the power rails. I think that might be coming through this funky connector. In fact, let me try and disconnect it while it's on and see what happens. Nothing. Okay, so it's reading it directly from the power connector. There's an LED tucked away up here, actually two of them it looks like. And there's also a small LED here for the CF card reader. It does eventually start blinking once it starts booting the operating system. There we go. Loading away. More LEDs over in the middle of the board by this NetLogic chip. Not sure what these are for. None of these are labeled properly except for the voltage ones, so I'm not really sure what those are for. And they do actually change patterns while it's booting up or something. I don't know. Down in this corner we've got the CF card slot for the front. Like I said, there was nothing in it when I got this. We've got a Xilinx chip over here, some SRAM, and a PMC class IPI. This is actually the PM2329. This appears to be for packet identification. So you can have this chip doing all the packet inspection work while the main processor is sitting just managing everything. One thing I've noticed, this is the biggest surface mount capacitor I've ever seen. It's huge. It's a 2200 mic cap, and I didn't even know they made them this big. It's absurd. I'm going to try and take that off just to take a look at it. There's programming headers everywhere on this board, although these particular ones are the COM ports. But as we get to it, you're going to see pins everywhere because there's so many chips that all need to be programmed. It's endless. Like I can't believe how much stuff is on this board. It must have just, well, that's why it costs so much, I guess. Over here we've got the Tildra. I'm not really sure. This is possibly a PCI bridge chip. I couldn't find much information on it. It's listed as the TSI 301-400CE, but I haven't been able to find any real information on it. It is a huge chip though, and there's power supply all around it. One little side note, these tantalum caps are really, really flat. I've never seen tantalums like that. I don't know if that's like a normal, I mean it's a normal size, it's just they're really flat. It looks like someone that you would pay extra for. Here's a good example. There are, oh wait, I can't get clear. There we go. Alright. These are like normal height ones, and then look at these. They're super flat. I don't know, like, are they paying extra to get these flat ones for no reason? I don't know. But there's the nice canned oscillators for, this is for the PMC chip, and this one's probably for the Tildra, whatever. Down here we've got this Broadcom BCM 5821. This is a 125 megahertz public key processor. Basically this can create like the encryption keys used for multiple connections, like through SSL and whatnot. So this thing can actually support up to 4,000 simultaneous SSL sessions per second, which is insane. Also down here is this little add-on board. I was wondering what this was at first, but then I saw the little TI logo. So that tells me this is probably a power supply, and I looked up the chip, and it's a Texas Instruments TPS 54910, which is a 9 amp adjustable buck converter. So that explains that. It's probably creating some weird supply voltage for the bigger Calindra chip up here. What is by far the largest chip on the board is this Broadcom C-Byte BCM 1250, which is a dual-core 64-bit MIPS RISC CPU with a DDR memory controller, 3 gigabit Ethernet ports. It's got hypertransport and a PCI interface. It's pretty crazy. It has 2 SD-RAM slots hooked up to it with 1 gig of total memory. It's made by TSMC, who make tons of different chips for tons of different companies, most notably AMD. All of their processors are made by them. They do this on a 860 ball BGA package, which is insane, and that's why the board is so many layers, most likely. And it only pulls 8 to 10 watts, which is really crazy considering it's a dual core processor. I think it's running at 600 or 800 megahertz per core. Just as a little side note, the Broadcom chip has the 2 memory slots for the SD-RAM. They're back to front. One is facing one direction and the other is facing the other. I have seen countless computers and electronics and stuff. Not once have I ever seen them do this with memory slots. The reason is these are connected in parallel normally. So you have each pin just linked together, right? And you join them up into banks. Why they would reverse it, I don't know. You're gonna have to run a trace from here to here and it's crazy. I don't know why it's like this unless these are 2 totally separate banks. I mean, it's possible because these are half gig chips or DIMMs, so it's possible it can only address 1 half gig per bank. So it is possible these are 2 totally separate banks and will operate independently, but it is very, very strange to have them reversed like this. Moving a bit further away from the Broadcom, we can see that there's another Xilinx controller. These are, I believe, Intel 10100 base T Ethernet controllers. There's another micro down here, programming ports for everything. This looks like some flash, another crystal oscillator. This is probably the flash for the Broadcom chip, the boot ROM. By the Broadcom is a huge power supply system, probably for the weird core voltages these things use. Towards the center of the board we have the management plug for the Ethernet, the shielded Ethernet cable running from it. There are these 2 NetLogic chips. I wasn't able to find any information on them. One is an NLNCP 80192. It has some SRAM attached to it. And the other one is an NLN SE70064. And I have no idea what they do. There's no information on them. They do have little 8-pin EPROMs next to them. No idea. They also have a little voltage regulator. Over here is the CF card. This is a Silicon Systems 128 meg, I like how it's listed as an SSD. This has not, I mean, it's pretty full, but all it has is grub, and it looks like a really basic Linux install just to get the software downloaded through TFTP. Because one thing I noticed in the information about this product is that one of the reasons why it costs so much is because it comes with a software server to manage multiple units. So I think what this system does is to prevent or to limit how much space you need on this, like no hard drive, to make it more reliable. It boots off this and tries to get the data from the server to continue booting. So I think that's why they can get away with only 128 megs of space on something that's doing a fairly complex task. Although there is flash hooked up to a lot of the chips, so it is possible it can do most of the stuff on its own. Now in the center of the board we've got this Vitrice, I'm going to say it's Vitrice IQ 2000. What this does is it's a packet processing engine used for things like deep packet inspection, where you're sending Ethernet traffic or internet traffic along through this machine, and this chip can inspect what's actually inside the packet as opposed to just looking at the addresses and stuff, and it can actually figure out the content of it and work out, whatever you need to do with it. Some systems use that information for throttling. For example, like cable companies will throttle your internet connection by looking for BitTorrent traffic, that sort of thing. This has a it's quad core 200 megahertz, and it has dual gigabit Ethernet built in, and it also interfaces with the dual RDRAM sockets. Here's one of the two RDRAM DIMMs, and it has 256 megs total. RDRAM is fairly uncommon. They kind of fizzled out. The only notable use of its future incarnation is in the PlayStation 3 and the Xbox 360. They use, I think it's called XDRAM, but it's basically a future version of RDRAM. It's a little weird. You actually have to put dummy cards in when there's no chip installed. Right next door we have this PMC RM7065A, which is around 300 megahertz 64-bit microprocessor. It actually has, it's most likely a MIPS based core. They weren't really specific, but it did mention the MIPS instruction set. What this is used for is high performance networking, 3D and video applications, where specifically you're doing more or less equal balance of integer and floating point math, because this thing has a very balanced work capability for each type of math. This is probably just doing more and more packet inspecting, like it's all part of it, or it's handling communicating, glue logic communicating to all the other chips. I'm not quite sure. Tied into the other Vitis chip is the Vitis Octal Mac. This is the VSC 2800. It appears to be an 8100 base T Ethernet port controller. It uses a special interface called the Focus 16. There's a 16 and a 32, which the other Vitis chip can interface with. And yeah, it's a specialized interface for communicating to the external chips. So they obviously have this tied right into its partner chip. There's also programming all around. These are the ones I cut off for the LEDs. I don't think they quite have enough relays in this thing. I think they need to add more relays. In the corner with all the relays, we have Broadcom 5228, which is a 10 base T Ethernet controller. And we have a more modern Broadcom 5421, which is a gigabit Ethernet controller, obviously adding more ports to the system. Around the LEDs, we've got this huge array of EEPROMs, a Cirrus Logic chip, some power supply stuff, all these pin headers. These go off to the power supply. There's just tons and tons of stuff just crammed into this one area. I'm not sure why these EEPROMs are just sitting here. Unless they're both wired into the Cirrus Logic, it seems a little weird that they'd just be off on their own, because every other chip seems to have its own. Off in the corner by the giant aforementioned 2200 mic surface mount cap is a ready-made Texas Instruments switch mode power supply. It's basically a big high current DC-DC converter. Last but not least, we have this daughter board off in the corner. It has 256 megs of PC100 SDRAM and a Celeron CPU over here. It's one of the mobile Celerons. It's 400 megahertz, 100 megahertz front side bus. It's the SL544. And yeah, this seems to be what's actually doing the work. Like, this is what the operating system boots onto. And we've got just basically a PC on a board, because it's got the controller chip for the CPU, and we've got a PCI bridge chip or PCI controller, and this is an I/O controller. So this one board essentially has a mini PC on it to most likely do all the management for the whole system. See, we got a couple, a lattice chip or two on it. Crazy. I noticed this interesting part on the daughter board. There's this huge resistor. Now I say it's huge because look at it. It's actually soldered side to side. It's not long. It's really wide. So this must be a very high current resistor. Not really sure what they're using it for. There's a bunch of looks like 100 mic caps here, and a big inductor. It's all power supply stuff, but I've never actually seen one in this package before. I wonder if it's like a specialty product that they had to order in or something. Seems a little weird. On the back of the board is just an endless sea of decoupling and huge caps, and what the hell, we'll put another Xilinx chip on the back. These are big ferrites, probably for the Ethernet ports, and a couple more oscillators on the bottom, and it's endless. There's just so much stuff on this board. Well, I hoped you liked taking a look at this ridiculously expensive piece of hardware, which is now 8 or 9 years old. Yeah, I got this thing a long time ago, and I was really putting off taking it apart because, or shooting a video of me tearing it down, because just the sheer number of chips, and I'd have to look up what they all do and stuff, and I just didn't have the time to do it. What I really wanted to do was shoot a video of something I could easily tear down and then throw out, so I could clear up more space. So this one kind of got stuck aside for months and months. So long, in fact, I originally was thinking it had a PowerPC chip on it when it actually has an Intel chip. But yeah, I finally tore it down. I'll probably take a couple pieces off these, like these kind of unique custom chips, because one day I may crack them open and examine them under the microscope. And of course, I want the relays. Always can use more relays.